a lot in ORMs. The index to prohibited features. So you come in and you look and the queries are performing badly, and you say, well, column, you're querying this column, maybe you should index it. Or you say, look, you're doing, customers doing a lookup, doing a big lookup across a huge field. Say, well, this is really what you're really trying to do is emulate full text search. Postgres has full text search built in. Why don't you use that? It's pretty cool. Or it has a built-in point type. You don't need to have an XY thing and do a query and all this stuff. It's really very nice. Or you have a multi-row constraint which you're enforcing inside the Python, but this bulk import process is running through a different code path and doesn't enforce it, so you're getting data that you think is bad. Just why don't you put in a trigger? And all this stuff. Interestingly, the full text search thing is very frequently you'll find customers running Solr, which was a scene-based search engine, not because they've really done a deep analysis and said Solr is superior, but because Solr has a Python interface that's really nice and easy to use. So they figure, well, we need full text search. We can't figure out how to use it through the ORM, so we'll add Solr into the mix to run it. There are people who need Solr as opposed to Python. Postgres is built in full text search engine, but that's kind of but most of the people who do this don't actually need Solr. And this is where we get to the problem with ORMs. There's the functionality that you end up with is kind of limited. It doesn't expose particular functionality, especially if this is functionality that's unique to a particular database product like Postgres, because they're trying to be database independent for those scenarios where somebody at midnight one day goes, let's switch to MySQL, because that always happens. This is especially bad if special syntax is required. Like in full text search, you need specialized operators. For point conversion, you need specialized operators. And without dropping down to the raw SQL level, there's no way of pushing the ORM to generate those operations. And this always happens 2 or 3 times a presentation as I hit the wrong button here. Bink. Ta-da. This is often claimed to be a feature is the problem is when you bring this up on the mailing list and say, well, but there's this problem, there is this kind of la 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 la, but what if we need to convert to MySQL overnight? It's like, that doesn't happen. It's these major database switches are not are not nearly as common as needing one of these features. But the story is always, but we're database agnostic. That's good, right? It's claimed to be it's a axiom without proof. That does not need to be proved. And frequently you get at these things is dropping into raw SQL, which again is doable, but means that you are once again buying a car just because you can still walk. And application programmers hate SQL. A number of times I get requests like, well, yeah, but can we still do it in Python? And we'll talk about what's going on behind this.
Is it not that the SQL or the SQL queries in their code? Because when you get to these kind of problems, the solution they find is to do procedures.
Well, yeah, we'll actually talk about that. I think the answer is sometimes it's both. Sometimes it's fear of SQL as SQL. The other one is they just don't like the way it looks, cluttering up their code with these big raw statements. And there are reasonable arguments they can make about dropping raw SQL, a giant raw SQL block, just in the middle of their code. There are ways we can fix that problem, of course, but sometimes there is this emotional reaction, and I think that can't be overlooked. But you're right. There are reasonable arguments to be made that, well, do we really want to drop this big, hard to maintain piece of query right in the middle of my otherwise relatively smooth Python? And then there's the opposite problem where the ORM helps too much. Client was getting all these deadlocks, and one of the things that ORMs kind of sell is, well, you're not going to get deadlocks. I've actually had people say, in as many words, it is impossible to get a deadlock if you use an ORM, which is an interesting definition of the term impossible. Because if you do, in the specific case, you deleted a parent record in a foreign key relationship, it was doing the on-cascade thing. Okay, that's fine. That's actually the default in Postgres. That's all right. The problem is that's not what we wanted. That relationship wasn't marked that way. It was actually marked as an onset null. Okay, that's weird. What's going on here? The problem was excessive help. They finally fixed this, but until the most recent, this is an example. There's plenty of other examples of the order helping too much. It was doing it on delete cascade whether you wanted it or not, and there was no way of turning this off, which is very helpful. And because the reason is SQLite doesn't have cascading triggers, cascading deletes, so we needed to implement it for database agnosticism. Well, that was helpful. Thanks. We appreciate the help. And why that particular feature? Who knows? You know, somebody ran into it. It was quickly slammed into the code base, and it was done. So, again, it's because it's having to, it's trying to be all things to all databases. You're getting these weird extra bits of help. So, who knows why? Yeah. Okay. So. They were doing a summarization operation, and they said, you know, it was like the total on an order or something like that. It was a fairly big, it was more than that, it was a fairly big one. So we looked at the database activity, and it selected about 125,000 records. Yeah. And did that. Okay. Yeah. So it was dragging in 125,000 records into memory in order to total one field. So this is and again, the reason is, and ironically, this was in Django, and Django supports perfectly nice operations for doing this kind of summarization, just the syntax on them is really ugly. So, but again, using this in-memory model inappropriately. So, oh, I duplicate that slide, I guess. Okay. So yeah, bad supporting. It's either the query reporting is support is bad, or the syntax is gross and horrible, and people don't want to use it. So it should just do a sum, because the problem was in Django, when if you're going to return these things as objects, it has to have a primary key, but what the primary key for reporting queries generally doesn't make much sense. So again, you can drop down to raw SQL, but you kind of get the idea. There's a lot of resistance to that. Memory disasters. So issued a query for all rows in a 12 million row table, did a sort for the first 10. Did a sort and was only going to take the first 10. And for reasons other, didn't do a limit line. Okay. So, no problem, Django queries are lazy. This actually works okay. It doesn't actually evaluate the query until you actually need the results. The problem is it touched the first record. So it did this query, came back, said, okay, I've got your results. It touched the first record, and bang, out of memory. Okay, and then you trace down in the code, and you say, well, Django, layer upon layer, I'm picking on Django, but that's only because I have the most recent experience fixing Django problems. Layer upon layer, Django was trying to do the right thing. It had generators upon yield operations upon this. It says, well, I'm only going to get the first 20 records and the first 20 records, and all the way down through to PsychoPG2, which is the most common PostgreSQL library for Python, and saying, I'm going to do a fetch one or a fetch many for 20. So please only give me 20 records. So that all seemed to be. So why was it running out of memory? Because it really doesn't understand how the DB interface works. You never use the name cursor in any of these operations. And so libpq, if you don't use name cursors, if you're just doing a select, the first time you say, give me the first record, the whole result set gets thrown over the wire. All 12 million records. And there's no clean way of getting around this in Django because named cursors are fundamentally a different SQL API than just doing a straight select. Which is frustrating because PsychoPG2 fully supports named cursors, and all you have to do is change the constructor on one object. But Django didn't know to call that. Now that was gross. And you know, I'm picking on Django, but something else. There's always somewhere where it doesn't really fully understand about how much data is about these problems of asking for 12 billion rows but getting them in bite-sized chunks. Somebody will break it somewhere. Yeah, okay. So, high log usage. This was generating like 12 gigabytes an hour of Postgres logs. These are the text logs, the text logs, not the write-ahead logs. Not the X logs. Well, that's kind of